Welcome to the DIY Honda Garage channel. DTC B1231, also referenced as Indicator 09 for vehicles with display, signals an issue with the evaporator temperature sensor circuit in the Honda CRV models from 2017 to 2022. The evaporator temperature sensor plays a crucial role in the climate control system by providing real-time data about the evaporator's temperature, which is essential for efficient air conditioning operation. An open circuit condition can lead to improper cooling and potential damage if left unchecked. Identifying DTC B1231 promptly is crucial to maintain vehicle comfort and to avoid more significant issues within the AC system. This guide will assist in troubleshooting the DTC effectively, helping technicians pinpoint the exact area of failure, be it within the sensor, wiring, or the climate control unit. DTC B1231 indicates an open circuit in the evaporator temperature sensor, which directly impacts the climate control function of the vehicle. The evaporator temperature sensor is responsible for measuring the temperature of the evaporator within the air conditioning system. This sensor is typically located within the dashboard area, close to the actual evaporator unit. Its data is vital for the climate control system to adjust the cooling settings accordingly. If this sensor circuit is open, it prevents communication with the climate control unit, leading to malfunctions in air temperature regulation. A thorough understanding of this component's role in the system helps technicians grasp why this DTC is significant. Several possible causes can lead to the DTC B1231 being triggered. An open circuit in the wiring can lead to interruptions in signal transmission, meaning the climate control unit cannot receive necessary data from the evaporator temperature sensor. A defective evaporator temperature sensor itself may fail to provide accurate readings, prompting the system to register this fault. Additionally, a malfunction in the climate control unit can also be a significant contributor, as other faults within this unit might not communicate effectively with the sensor circuit. Identifying these root causes quickly is essential for an efficient repair process and ensuring the air conditioning system functions smoothly. When DTC B1231 is present, several noticeable symptoms can manifest. Most prominently, an inconsistent cabin temperature is typically experienced by occupants, as the vehicle's air conditioning system cannot accurately regulate itself without proper feedback from the evaporator sensor. Furthermore, poor air conditioning performance combined with inadequate cooling can become apparent during operation. Additionally, the DTC indicator will illuminate on the dashboard, signaling to the driver that a fault has been detected within the climate control system. Paying attention to these symptoms can help ensure timely diagnosis and repair of any underlying issues affecting passenger comfort. Initiating the troubleshooting process for DTC B1231 begins with problem verification. First, the diagnostic handheld scanner, HDS, is used to clear any existing DTCs, ensuring a clean diagnostic slate. Once cleared, it's essential to turn the vehicle to the off position, followed by switching it back to on. This action resets the vehicle's systems and allows for a proper self-diagnostic function to engage either through the HDS or directly via the climate control unit. Following these steps will either confirm the presence of DTC B1231 again or indicate intermittent failures, leading to further investigation steps. The awareness of these procedures helps in establishing a clear diagnostic direction. Continuing the troubleshooting process involves verifying any potential short circuits in the TEVA line related to power supply. Start by turning the vehicle off and disconnecting the climate control unit connector B, 24P. With the unit disconnected, switch the vehicle back to on mode. Next, the technician will measure the voltage between the designated test points, connector B, number 8, and the body ground. If voltage is present, this indicates a short to power exists in the TEVA wire, necessitating immediate repair to prevent further complications in the system. Conversely, if no voltage is detected, this suggests the TEVA wire is intact, prompting further investigation. The next step involves determining the possible failure area, focusing significantly on the climate control unit. With the vehicle off and the climate control unit connector B24P still disconnected, resistance measurement between specific terminals must be performed. The technician should connect the resistance meter between connector B number 8 and number 10. Reference resistance values established indicate acceptable ranges corresponding to various temperatures. If the measured resistance falls within the acceptable range, the climate control unit is functioning properly. However, if the readings are outside the acceptable limits, the technician should proceed to replace the unit, as it likely indicates failure of the climate control system. To further investigate the wiring integrity, the next troubleshooting step involves checking for an open circuit, specifically in the TEVA line. Begin by disconnecting the evaporator temperature sensor 2P connector, while the climate control unit remains disconnected as well. The technician will check for electrical continuity between test points specified in the procedure. Connection at climate control unit connector B24P, number 8, and sensor connector number 1. A successful continuity check means that the TEVA wire is functioning appropriately. However, if continuity is not present, it suggests an open circuit exists in the TEVA wire that requires prompt repair to restore proper signaling to the climate control system. The final troubleshooting step focuses on assessing the sens-com line continuity to ascertain whether the evaporator temperature sensor itself requires replacement. Following the same disconnection protocols, the technician should check continuity between climate control unit connector B24P number 10 and the sensor connector number 2. Successful continuity indicates that the sensor is functioning properly, while a lack of continuity suggests an open circuit within the sens-com line, prompting the need for repair. If continuity is present, but the issue persists, the technician should consider replacing the evaporator temperature sensor. This thorough check ensures that the primary components of the climate control system are functioning optimally. Upon completing all necessary repairs and replacements, it is crucial to perform a final verification of the repair. This involves rechecking for any DTCs using the HDS to confirm the absence of the previous error. The technician must then ensure that the newly replaced or repaired evaporator temperature sensor is functioning properly, which may involve a simulation of the various temperature ranges. Following these checks, it's essential to test the overall performance of the air conditioning system, confirming that it cools effectively as intended. This systematic approach guarantees that all issues are resolved and that the vehicle is returned to optimal operating conditions, providing the necessary comfort for the occupants. To prevent the recurrence of DTC B1231 and related issues in the future, it is vital to practice preventive maintenance diligently. Regularly checking wiring connections, especially those associated with the evaporator temperature sensor and climate control unit, helps to identify looseness or potential wear early on. Additionally, periodic inspections of the sensor itself and its location for any signs of damage or exposure to elements can aid in early detection of faults. Performing complete system diagnostics routinely allows for timely adjustments and repairs, minimizing the risk of failure. This proactive approach ensures long-term reliability and optimal performance of the vehicle's air conditioning system, enhancing overall driving experience. In summary, DTC B1231 represents an open circuit in the evaporator temperature sensor circuit, significantly impacting the air conditioning performance of Honda CRV models from 2017 to 2022. Understanding the critical role of the evaporator temperature sensor within the climate control system is essential in diagnosing and addressing this issue effectively. Following the troubleshooting steps methodically ensures that technicians can accurately identify the source of the problem, be it wiring, a faulty sensor, or a malfunctioning climate control unit. By also implementing preventive maintenance practices, vehicle owners can mitigate risks of similar issues arising in the future. Thoroughness in repair verification emphasizes a commitment to providing a comfortable driving experience for all passengers. Please like and subscribe to the channel. See you next time.